Welcome to a whistle-stop tour of the Scuderia Toro Rosso factory in Faenza, Italy, and its wind tunnel in Bicester, England. All Formula One cars look very similar to one another because they all have to comply with very strict technical regulations set down by the FIA, the federation that governs the sport. Their main concern is safety, while the new rules for 2014 onwards also acknowledge the sport has to head for a greener, more ecologically responsible future. F1 development is therefore a constant battle between the rule makers and the cleverest brains in motorsport, who are always thinking of getting round the rules to squeeze more speed out of the cars. What makes the difference is the way each team interprets those regulations, trying to get the most performance out of each component to ensure the car generates as much downforce as possible, that the relationship between the suspension and the aero parts is at its most efficient. This and so many other parameters, when put together in the best way possible, can produce a Grand Prix winner. Designers look at the rules and decide where they want to go, putting together an outline of bodywork, power unit, suspension, tires and so on. A designer might even use an old-fashioned drawing board. But the bulk of work is done on a computer using a program known as CAD, Computer-Aided Design. This allows designers to work on every part of the car in 3 dimensions on a screen, producing thousands of drawings for each new car. How can you tell if the design is going to work? More computers this time operating a system known as CFD, or Computational Fluid Dynamics, which gives an initial analysis of all the design work done so far. It looks at the flow of air around the car, seeing how to get the best out of each item singly and as part of the overall package in terms of its aerodynamics, currently the most important factor for car performance in Formula One. CFD can even assess the effect of heat from the engine and other components on the rest of the car. Once it was thought that CFD would do away completely with the need for a wind tunnel. But it hasn't, which is why one of the biggest departments within Scuderia Toro Rosso is the wind tunnel, based in Bicester in England's Formula One Valley. A designer has an idea, it's drawn on computer, and then it has to be made into a model for testing on the scaled-down F1 car on a rolling road in the wind tunnel. This is where speed of work can lead to speed on the track. The difficulty is making that part for the model quickly, evaluating it, then getting the actual part designed in the design office, after which the drawings have to go to manufacturing for the part to be made. Safety is the most important consideration in Formula One, and while a part can be designed that's effective and make the car go quicker, unless it can withstand the huge loads placed on various elements of a car, it cannot be used. This is where the Research and Development Department in Faenza comes in, testing parts under load, often to breaking point. The department's staff know exactly how strong each component must be, but the standard is set by the federation that runs the sport, and each new car has to undergo stringent crash testing, with impacts of different forces placed on the car's monocoque from different directions. So far, no one has got their hands dirty in building the new car, but now it's time to see the machine shop where the car actually starts taking on a real form. In the machine shop, we produce custom-made metal parts and the molds for the carbon fiber lamination. A clever machine called an SLS, or rapid prototyping machine, that can turn around parts for the wind tunnel very quickly. And of course, parts for the actual car. Turnaround time at this stage is very important because it's not a case of building parts at the start of the year only. As designers come up with ideas aimed at making the car faster, new parts are required. sometimes within days, to be shipped off to the next race. Racing cars used to be made of aluminium body panels fitted to a steel space frame of tubes. Then in the 60s there was a switch to an aluminium monocoque construction, doing away with the need for a space frame. Then in 1981 came the first ever carbon fiber composites monocoque, which revolutionized the sport. As time passed, more and more parts were made of this incredibly strong material, replacing the more conventional steel and alloys. Until today, almost the entire car, chassis, bodywork, suspension is made from it. Hence the importance of our composites department. Carbon components are made with several layers put down in various different ways depending on how flexible, strong or rigid they need to be. Once laid up, they're vacuum packed and then cooked in the autoclave, which is essentially a giant oven. Motor racing is dangerous. It says so on every admission ticket around the world. Therefore, the work of the Quality Control Department is vital, using laser scans of parts and other sophisticated crack testing and lifing equipment to ensure that parts, both brand new as well as those that have returned from a Grand Prix weekend, are good to go again. The workshop is at the heart of every team. It's the place where things get very exciting, especially just before the start of every season, because this is the place where the thousands of components finally come together and form a Formula One racing car, one of the most sophisticated vehicles in the world. The use of computer design has revolutionized the car assembly, as parts tend to fit as they should without the need for modification. However, the skilled mechanics who put everything together for the first time provide valuable input regarding how easy the car is to work on, which becomes of vital importance when time is tight at the racetrack, and changing a rear wing as quickly as possible can impact performance. Although the pace of work steps up a gear in the lead to the start of pre-season testing, the factory departments are never idle, because the Formula One car that rolls off the production line in February is never the same by the time the last race comes around 10 months later. The designers never stop looking for ways to improve the car's performance based on data gathered from testing and the races. It means more good ideas, more wind tunnel hours, more manufacture and testing, and hopefully more World Championship points.